Hi everyone. So in this video I'm going to do two examples of how to graph a polar equation. So this is the first example. So graphing a polar equation is actually quite tricky because you don't really visualize this as up, down, left, or right. You visualize this as you rotate around the circle, how far away from the origin are you going? So theta is the rotation, r is really the distance away from the origin, and we're going to graph this on the xy plane. Okay, so I'm going to draw the xy plane. Okay, so we're going to see the relation of r to theta, which is the rotation around this xy plane. But it's actually quite tricky to kind of see the relationship between r and theta in this xy plane. So what we're going to do is we're going to look at the r theta plane. So this equation in the xy plane is a polar equation. But the same equation, if I take the same equation and I view it in the r theta plane, this r theta equation is really a rectangular equation. And that's because in this world, r is your vertical axis, theta is your horizontal axis. And by graphing this in this rectangular world of r and theta, it will help guide me on how to graph r and theta in this xy plane. Okay. All right, so let's begin. Now this guy, the amplitude we know is a 3, and we're going to look at the period, and we learn that the period is always 2 pi divided by that coefficient in front of theta, or in front of this variable inside, so my period is pi. And that's a cosine, so we're going to go as far up 3, and -3 is as far as we go down. And for cosine, and to complete a period, we got to go to pi half. So at this point, in order to really understand how to graph a polar equation, you have to really understand trigonometry. So when I draw this, you should know exactly what I'm doing, and everything should make sense. Right, it's a cosine graph, amplitude is 3. So halfway through the period, which is at pi half, I'm at -3. Okay, I'm going to call this guy point A. I'm going to call this guy point B. I'm going to call this guy point C, point D, and point E. Now that's really all we need to understand this graph. So let's go back to the xy plane. In order to understand this graph, I would have to rotate theta around not just pi, but really 2 pi. So to understand this graph, I have to understand what theta is doing from 0 to 2 pi. So even though the period really ends at pi, I would have to graph this guy all the way to 2 pi. But I know what the is because it would just repeat itself. So okay. So this point here is pi. That's pi half. That's pi over 4. So really pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. So this guy is 5 pi over 4, 6 pi over 4. This is 7 pi over 4. And this is really 8 pi over 4. So that's point A, B, C, D, E. I'm going to call this guy point F. And this is point G. This is point H. And the very last point is point I. Any point with the radius being 0 would be right on the origin. So without even having to graph B, D, F, and H, I know they all would land on the origin because my radius is 0. Doesn't matter which direction I'm pointing in. If my radius is 0, I am on the origin. Okay. So how would this graph help me to visualize what's going on in the XY plane? So theta is the rotation around the circle. R is how far away the origin you are. So if I look at my R theta plane, when theta is 0, my radius is 3. So where would point A be? When theta is 0, when angle is 0, my radius is 3. So I need to know how far away it really is 3. So this would be point A. Because at angle 0, I am a distance of 3 away. Where would B be? At angle pi over 4, my radius is 0. So in the direction of pi over 4, if my radius is 0, well, you end up right on the origin. So that's point B. I'll write it, but I'll keep it small. Okay. So where would C be? At angle pi half, my radius is -3. So here's angle pi half. This is towards the positive direction. If my radius is -3, that means I go in the opposite direction. So in the direction of pi half, a -3 would actually go in the opposite direction, which is downward, and then you end up down here. Well, D, again, that's the origin. How about E? E is at the angle pi, and at the angle pi, your radius is 3. So here's the angle pi, and towards that direction pi, I'm going to go a distance of 3. And that would be my point E. Okay, F, well, radius is 0, so you're right on the origin. G is the angle 3 pi over 2. So this is 3 pi over 2, that's pointing downward. But at 3 pi over 2, my radius is a -3. So at 3 pi over 2, which is pointing downward, if your radius is a -3, you're not going to go towards this direction. You're going to go in the opposite direction. So at 3 pi over 2, a radius of -3 means I actually would go up. So you end up right there. So this point G is going to be up here. Okay. All right. And point H is on the origin. Let's try I. I is when it's pi, 2 pi. So in the direction of 2 pi, which is also 0, same thing, you are a distance of 3. So it turns out I is A. So now we've actually gone back to that starting point. So this will be some sort of a closed loop, okay? So how do I go from A to B? How do I connect A to B? Do I just go straight? Do I go up and down? Well, the relationship is that as theta, which is the angle, as it increases from 0 to pi 4, as my angle increases from 0 to pi over 4, so here's angle 0, here's pi over 4, what's happening to my radius? My radius starts at 3, but as my angle increases, my radius actually retract back to 0. So as my angle increases, it gets smaller. And when you reach pi over 4, it gets small enough where it will go to 0. So if you trace that as angle increases, radius decreases, angle increase, radius decrease. So if you kind of just trace that continuous motion, yeah, see that? It'll be some sort of a, it'll look something like this. Okay. So at pi over 4, you are at 0. So from 0 to pi over 4, this is the positive. From pi over 4 to pi half, that's the positive. But from pi over 4 to pi half, if that direction is positive, the negative direction is down here. Right? Positive r, negative r for any angle between pi over 4 to pi half. So now that you're at B, we're going to go towards C, which is from pi fourth to pi half, but you notice that all my radius is negative. So from pi fourth to pi half, because all my radius is negative, I'm actually not going to go towards this positive direction. I'm going to go towards the negative direction. So as my angle increases, my radius would actually decrease even further, going to the negative direction. So at pi fourth, it's 0. But once you go past pi fourth, now my radius is going to be a negative. So it's going to protrude towards the negative direction. And as you increase the angle, the radius would decrease further into the negative. So as angle increases, radius decrease towards -3. Okay? Okay, so that's C. From C, you're at pi half. D is at 3 pi over 4. So here's 3 pi over 4. To increase the angle from pi half to 3 pi over 4, pi half to 3 pi over 4, your radius starts at -3, but it will get less negative and it will go towards 0. So here's the positive r from pi half to 3 pi over 4. But if you reflect that, here's the negative r. So as you increase the angle from pi half to 3 pi over 4, your radius will actually be less negative. It will go towards the 0 radius. So as angle increases, radius would decrease and it will go towards 0. Okay. So that's point D. Now to go from D to E, you're going to increase angle 3 pi over 4 to pi. So here's 3 pi over 4 to pi. As you increase your angle from 3 pi over 4 to pi, your radius starts at 0, which is at the origin, but as my angle increases from 3 pi over 4 to pi, your radius will increase from 0 to 3, which means that as my angle increases, my radius now would increase towards 3 as well. So as the angle starting at 3 pi over 4 increases to pi, my radius would also increase. Okay, so if you kind of follow that motion, as the angle increases, the radius also increases out to 3. So if I point towards 3 pi over 4, my radius is 0, but as I increase my angle, my radius would increase towards, and once I reach pi, I'm at 3. And so that would trace out this motion. So it's just a trace of the relationship between r and theta by this equation. Okay, so that's E. And then from E to F, which is from pi to 5 pi over 4, you start off at a radius of 3, but as I increase my angle, my radius would now go back to 0. So that pi to 5 pi over 4, as I increase my angle, my radius would now retract back to 0. Okay. And you can kind of see a relationship here. This trace is this. So for every bump, we get a pedal. So for this bump down here, this bump corresponds to this pedal. And if I continue on, you'll see that G at 3 pi over 4 is up here. At some point, you pick up the pattern, and you can kind of complete the rest of the graph by just following along this pattern. So this is going to be the graph of this guy. And I'm using this rectangular graph of r and theta in the rectangular plane of r and theta to help me guide along this relationship between r and theta in the xy plane. Okay, let's do one more example. So here I have r is 5 sine of 3 theta. And I'm going to graph this guy in the xy plane. And I'm going to make sure to get a nice big graph. Okay. So I'm going to graph this on the xy plane. So r is the distance away from the origin, theta is the rotation. But if I graph it in the r theta plane, this guy is a rectangular graph. So r is the vertical distance, theta is the horizontal. So this is your standard graph, rectangular graph. A is 5, that's amplitude. If you have a 3, then your period is going to be what? 2 pi over 3. Okay. And, well, here's the first sine, which is 2 pi over 3. Half of that is pi over 3. Half of that is pi over 6. And so this is pi half. So that's pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. And this is a sine graph that go towards 5 and negative 5. And so it's going to look something like this. Okay. And this is all you need to understand this graph, but to understand this graph, this polar graph in the xy plane, I need to understand how it's behaving as I rotate a full circle on this guy. And to rotate a full circle, I need theta to go all the way to 2 pi. So I need to graph this guy all the way to 2 pi, even though a period ends at 2 pi over 3. So how many period do I need to get to 2 pi? Well, 2 pi over 3 plus 2 pi over 3 plus 2 pi over 3 is 6 pi over 3. That's 2 pi, so I need to draw 3 periods. So I'm going to copy this guy over. Okay. Do that again. It's going to be exactly the same thing. Now that's 2 pi over 3. That's pi 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. This would be 5 pi over 6, 7 pi over 6. 8 pi over 6. What is 8 pi over 6? That's a 4 pi over 3. 9 pi over 6, which is 3 pi over 2. 10 pi over 6, which is 5 pi over 3. 11 pi over 6. And this is 12. I think I skipped one. 9, so that's 8, 9, 10, 11, 12. So which one did I skip? 1, 2, 3, 4, 5. Oh, this is 6, so that's pi. So this is pi. This is 7 pi. So 7 pi over 6. So this is all off. Sorry, guys. This is 11 pi over 6. And here's 2 pi. Okay. I'm just going to graph a few of these until you can kind of see the pattern. I'm going to call this A. I'm going to call this B. Call this C, D, E. And you'll see that each of these bumps will form some sort of a petal. And you'll get some sort of a rose, a flower. Okay, so where's A? Well, A is when the angle is 0, your radius is 0. So that's A. But as my angle increases to pi over 6, well, pi over 6 is your 30 degree. This is 90 degree. So 30 is 1/3 of that. So here's pi over 6. And then here's pi over 3. And then here's that's pi half. And that's 2 pi over 3. And here's 5 pi over 6. Right? So from angle 0 to angle pi over 6, my radius would increase from 0 all the way to pi. 5. So let's say this is 5. So as my angle increases from 0 to pi over 6, my radius actually increases all the way to 5. So by the time my angle gets to 5 pi over 6, here's my angle 0, here's my angle pi over 6. By the time I get to pi over 6, I'm actually protruding it out towards a distance of 5. So it's pretty fast. So you can kind of see if I trace that. That's already half a petal, right? Now from B to C, which is pi 6 to pi third, as my angle increases, my radius is now going to go towards 0. So from pi 6 to pi third, as my angle increases to pi third, my radius would now decrease back to 0. So my first petal was formed between angle 0 and pi third. So this guy corresponds to this guy. Now what's happening between pi third and pi half? Here's pi third and pi half. Pi third and pi half in this direction, here's the positive direction, but pi third and pi half, you notice that all my radius is now negative. So I'm going to end up in negative. So where's the negative? So if I extend this direction, pi third, and I keep on drawing, and I extend this pi half and I keep on drawing, this is the positive region for the radius from pi third to pi half. On the other side of that would be the negative, so it's this guy. So this line here, I'll use red, should end up somewhere down here. So as I trace C to D, C is radius 0, so that's on the origin, but as my angle increases, my radius is now going to decrease all the way down to -5. So as my angle increases from pi third to pi half, my radius would protrude out towards the negative direction until I reach a distance of -5. Okay, so it's gonna look something like that. And from pi half to pi third, pi half to 2 pi over 3, right? That's E. So this is D. E is at the origin. From pi half to 2 pi over third, pi half to 2 pi over 3. Here's the positive for that. Here's the negative. It's going to retract back to 0. So this guy is going to complete that petal. So this guy corresponds to this. And I can keep on going, and I'll be able to complete this graph. So my challenge for you guys is to complete this graph and check your answer online. Okay? So E, A, B, C, D, E, F is G. So at 5 pi over 6, you're at radius 5. 5 pi over 6, you're at radius 5. So this should be F. And here's your next petal. Okay? It turns out the last 3 petals will just kind of overlap. So this guy is this guy. And when you move on to the next petal, even though it is a new one, it's going to overlap with the first one. And I'll let you confirm that yourself. But this would also be in here. Okay. All right. So in the next Zoom meeting, I'll do a few more examples, and I'll answer any questions you guys might have.